Hey guys, we're on Unit 4 and we are on day 5. This is rotations. And in our warm-up, it says that angle A and angle B are complementary. Complementary are two angles that add up to equal 90 degrees. Okay, and then they're telling us that angle A is x plus 42 and angle B is 2x minus 12. So those two angles are going to add up to equal 90. So we're going to say x plus 42 plus 2x minus 12 equals 90 degrees. And they want us to find the measure of the smaller angle. So we got to solve for x first, and then we'll plug in. Okay. We have an x plus a 2x, which is 3x. 42 minus 12 is positive 30, equal to 90. We're going to subtract 30. We're going to get 60. We're going to divide by 3, and x comes out to equal 20. Now they want to know the measure of the smaller angle. I'm not quite sure which one's smaller, so we're going to plug into both. Angle A is 42 plus 20, which would make that 62. And I'm pretty sure that that's going to be the larger angle, because if they add up to 90, 62 is going to have to be the bigger one. Okay? If we plug in 2 times 20 minus 12 is 40, and 40 minus 12 is 28. And they wanted the smaller angle, so that would be angle B. Okay, so we're going to talk about rotations today. They're going to be a little bit tricky, especially on a video. So we're going to give it a shot. So this is a transformation in which a figure is turned about a fixed point called the center of rotation, and that point of rotation is going to typically be the origin. Degree of rotation is the number of degrees the figure rotates. Rotations that are counterclockwise are positive. Okay, counterclockwise is going to go the same way the quadrants go. Okay. Rotations that are clockwise are negative degree measures. Okay, they go the same way the clock goes. Rotation notation. We've talked about this before, but they use the capital R. The O is the origin, and then the number of degrees goes second. Okay. All right. We'll slide down. There's a little picture of a rotation. You can see that we have an original triangle called QRS. Okay. We have the point of rotation, or the center of the rotation, and we are rotating in a counterclockwise manner, and so that would be positive degrees. Okay, notice the triangles don't change shape and they don't change size, and so those are our properties of transformations. Okay, the distance between 2 points in the original is no different than the distance between 2 points in the image. So distance is preserved or kept the same. Angle measure. If we were to measure the number of degrees in angle Q, or any of the angles, okay, and match it up with its corresponding angle, it's going to have the same number of degrees, and so angle stayed the same, or they call that angle preserving. And therefore, since both of them preserve distance and angle measure, then rotations are called rigid motions. You're doing a motion by turning, but the triangle is staying what they call rigid. It's staying the same size because the distance is being preserved, and it's staying the same shape, triangle, because the angles are being preserved. Okay. See if we can identify these 4 on the bottom. It says in number 1, tell whether each transformation is a rotation. And rotations are tricky because you have to turn them kind of in your mind, but this one is a no. Okay. This looks like a reflection instead. Okay. Second one up, if you were to turn that one would match up, and you would have to turn it 180 degrees or upside down. Okay. This next one does look like a rotation. If this triangle goes this way, that would be a positive 90 degrees. Okay. If it went the other way, or you can keep going with that one all the way around, but either one. So this would be a yes, and you could say that it would be 90 degrees. Okay. If you took this triangle and rotated it this way, then that would be 270 degrees. Okay. Or you could take the triangles and rotate them clockwise instead, and then you could talk about negative degrees. Okay. And then the last one, if we try to turn that upside down, that is not going to match. That one's a little bit tough to picture, but it would look more like this instead if we turn this one upside down. In fact, it would look, I think, pretty similar to this picture, right? And so because it does not look like this one is a no. Okay. All right. We'll see you guys on the backside notes in the next video.